Hello, in this lecture I will talk about mathematical induction. Mathematical induction is a logic method that makes it possible to prove that a certain property is common to all natural numbers. The proof by induction consists of two claims. First, that the number 1 holds the property, and the second, that if a natural number n holds it, then the number n plus 1 also holds it. The flexibility of induction method has made it one of the most powerful proof tools in any mathematician's toolbox. The main points of the argument is that the proof by induction has two parts. First, it is shown that the number 1 fulfills the desired property. This is the basis of the induction. And secondly, that if number n fulfills it, then the number n plus 1 also fulfills it. This is the induction step. If number 1 satisfies the property and its correctness for n also follows from its correctness from n plus 1, then all natural numbers satisfy the property. Now I will talk about the structure of the proof. The structure of the proof in induction is always the same. A test for the case n equals to 1, an assumption for general n, and the proof that from the assumption follows the correctness of the claim for n plus 1. Okay? Now I will give you example for mathematical induction. We will prove the formula n plus 2 plus 3 plus 4 equals to n times n plus 1 divided by 2. For n equals to 1, it is very simple to see that it is true. Because in this case the value of both sides is 1. As you can see here, for n equals to 1, it is 1 times, in brackets is 1 plus 1 divided by 2, so it is 2 divided by 2 equals to 1. So 1 equals to 1. Second, we will assume that the statement is true for n, that is n plus 2 plus 3 plus 4 plus n equals to n times n plus 1 divided by 2. So we will assume that this claim is true for n, okay? So this is the assumption of the induction. We assume that this equation is true for n. So we assume that this statement is true, okay? And then we will prove it, the equality for n plus 1. So for n plus 1, we have to prove that 1 plus 2 plus 3 plus n plus 1 equals to n plus 1 in brackets times n plus 1 plus 1. That is actually n plus 1 multiplied by n plus 2 divided by 2. Okay? By the induction hypothesis, we can write, instead we assumed that this expression equals to n times n plus 1 divided by 2, okay? So actually we can replace this expression by n times n plus 1 divided by 2. Okay, so here we replaced this the previous expression by n times n plus 1 divided by 2, because this equation we assumed that is true for n. So the true statement is that 1 plus 2 plus 3 plus n equals to n times n plus 1 all divided by 2. Okay? And then we have n plus 1. And actually we must prove that this expression is equals to n plus 1 times n plus 2 divided by 2. Okay, that is the proof for the proof of the claim for n plus 1. So we will develop this expression. Actually, n times n is n squared, n times 1 is n, and here we have n plus 1. So if we put n plus 1 actually we multiplied n plus 1 by 2 and then divided it by 2, so we changed nothing because we multiplied it by 2 and then we divided it by 2. So n plus 1 multiplied by 2 is 2n plus 2, and all divided by 2, and this equals to n squared plus 3n plus 2 all divided by 2, because here we have n squared and n plus 2n is 3n, and here we have plus 2, so we put here plus 2. Okay, and this is n squared plus 3n plus 2 equals to n plus 1 times n plus 2 divided by 2. And this is exactly what we have to prove. We proved the claim for n plus 1. Actually, we assumed that the claim is true for n, and then we proved it for n plus 1. Actually, we proved that the claim is true for n plus 1, because for n plus 1 we have 1 plus 2 plus 3 plus 4 plus n plus 1 equals to n plus 1 times n plus 2 divided by 2. And that is exactly what we proved here. We proved here that 1 plus 2 plus 3 plus n plus 1 equals to n plus 1 times n plus 1 times n plus 2 divided by 2. So actually we assumed that 1 plus 2 plus n equals to n times n plus 1 divided by 2. That was the assumption of the induction, and according to the assumption of the induction, we proved the claim for n plus 1. Actually, we proved that 1 plus 2 plus 3 plus n plus 1 equals to n plus 1 times n plus 2 divided by 2. Okay, so that is what we needed to prove. Okay, thank you very much.